Alright folks, this is once again Ted the Speed Learner, and this is Euclid Book 6 proposition number 10, and it says to cut a given uncut straight line similarly to a given cut straight line. Let AB be the given uncut straight line. I know it doesn't look uncut right now, but it was when I started this, and AC be the straight line cut at points D and E. Okay, so let's start with this line here. You have your AB, and it's supposed to be uncut. Then you have your AC up here, which is supposed to be cut. Okay? And AC is cut at points D and E. So AC here has been cut at points D and E. Just like that. Okay, and you're supposed to let lines AB and AC be placed at any given angle. We don't care what the angle is. Let CB be joined. Well, here's CB, and we're going to let it be joined. And through D and E, here's D and E, through these two lines here, let DF and EG be drawn. Okay, this is DF, and this is EG. These two lines will be drawn parallel to BC. And through D, let DHK right across here. It has to be parallel. It has to be parallel to line AB. Well, here's line AB, and DK right. DHK is parallel to AB. And this is by Euclid Book 1, proposition number 31. Therefore, each of the figures FH and HB is a parallelogram. Well, where's FH? Well, this would be parallelogram FDHG. That's this parallelogram. And HB, well, HB is this one, HGBK. So both of these are parallelograms. Therefore, DH is equal to FG. DH is equal to FG. And HK to GB. HK to GB. And this is by Euclid Book 1, proposition number 34. Now, since the straight line HE has been drawn parallel to KC, since HE right here, there's your HE, and has been drawn to parallel to KC, right there. And by the way, HECK is also a parallelogram, so you got 1, 2, 3 parallelograms right here. Just wanted to establish that. And KC happens to be one of the sides of triangle DKC. So you have DKC, and KC happens to be one of the sides of DKC. Okay? Therefore, proportionally, as CE is to ED, as CE is to ED, so is KH to HD. KH to HD. As this is to this, so as this is to that. Okay. Now, KH equals BG. KH equals BG. This one equals this one. And HD equals GF. HD here equals GF right here. So, as CE is to ED, CE is to DD right here, so as BG is to GF. BG is to GF. So as this is to this, so as this is to that. And now we can say that FD is parallel to GE. Well, FD here is parallel to GE. These two lines are parallel. And GE happens to be one of the sides of AGE. Well, here's triangle AGE. GE, and GE happens to be one of the sides of triangle AGE. So as ED is to DA, ED is to DA, this is to this, so is GF to FA, GF to FA. And this is by Euclid Book 6, proposition number 2. But it was also proved that as CE is to ED, as CD is to ED, so is BG to GF. BG to GF. We already proved that this is to this as this is to this. Therefore, as CE is to ED, as this is to this, so is BG to GF. BG is to GF, we already said that. And as ED is to EDA, ED is to DA, so is GF to FA, GF to FA. As this is to this, so as this is to that. Okay? Therefore, the given uncut straight line AB has been cut similarly to the given cut straight line AC. And there you have it, folks. There's your proof. I will tell you more in a future video, so stay tuned.